Okay, these notes are the concept number 1 for quarter 3. So this is absolute value equations. Now, what's going to be the most important thing to remember the entire way through this absolute value section is that absolute value is simply asking you what is that number's distance from 0. Okay, so if you think about a number line, we are trying to figure out how far away is a certain value from 0. What also is very important to remember is that a distance could never be negative. Okay? I can never have a negative distance. I can't run a negative 4 miles. I can't drive a negative 4 miles. Okay? Distance is not allowed to be negative. So if we just look at two plain simple examples of just finding the absolute value of a number. If I give you the absolute value of -2, that is asking you what is the distance of -2 from 0. So if you think about a number line, -2 is 2 away from 0. So its distance is a +2. Okay? It takes me 2 units to get from 0 to -2. Okay? So -2's distance from 0 is 2. Then if I had the absolute value of 7, that's again asking what is this value's distance from 0. Well, again, if you think about plotting this on a number line, the value of 7 is 7 units away from 0. So the answer is a +7. Now, second example is actually working backwards. Okay? I don't know what this value is inside of the absolute value bars, but I do know that this number's distance is 4. Okay? They're telling me that the absolute value of x, right, so just some number, is equal to 4. Okay? So the distance is 4. So now you have to think backwards. What number could be inside of this absolute value? Okay? What number would have a distance of 4 from 0? Well, there's 2 answers for that. This number could have been a +4 in here. If I think about a number line, 4 is exactly 4 units away from 0. Okay? So the absolute value of 4 is 4. But also, this could have been a -4 in here. -4 also has a distance of 0, or a distance of 4 from 0. Okay? So you have 2 answers in this case because I'm working backwards. I'm trying to find the value inside of the absolute value bars. Okay? I know the distance. I'm trying to find the original value. So I have 2 answers. X could have been 4, or x could have been -4. So if we look at this example here, absolute value of x equals 7. So again, they're telling me the distance because they're telling me what this is equal to. So I know that this number's distance from 0 is 7. So I have to decide, well, what number or numbers has a distance of 7 from 0? So in this case, again, you have 2 answers. This value could have been a +7. Right? +7 has a distance of 7 from 0. Or this could have been a -7 in here. -7 also has a distance of 7 from 0. Okay? So you have 2 possible answers for what x could have been. Okay? You can also check this by plugging it back in, which is what I just talked through. Absolute value of 7 is equal to 7. Absolute value of -7 is equal to 7. Now, next example here, absolute value of x equals a -10. So again, this is asking us what value or values, what numbers, have a distance of -10 from 0. Again, we cannot have a negative distance. It's not possible to have a distance that is negative. So because this is not possible, your answer is a no solution. Okay? You can never have an absolute value that equals a negative number. Okay? Because again, this absolute value is asking you this number's distance from 0. Okay? There are no numbers that have a distance of -10. All right, bottom example here of the absolute value of x minus 3 is equal to 8. So now this is a little bit bigger than the previous examples that we did. Remember that what's inside of here, okay, had 2 options. if this value inside of the absolute value bars has a distance of 8, right? Again, you have to think back to what this could have been. Okay? We have two options. Inside of here could have been a positive 8, or inside of there could have been a negative 8. Okay? So you have to set up two equations because, again, I have two possibilities of answers. So this x minus 3 could have been an 8. Okay? X minus 3 could equal 8. Or this x minus 3 could also be a negative 8. So x minus 3 equals negative 8. So you need to take this inequality, or this equation, and split it into two new equations. Okay? When you make that split is when you drop the absolute value bars. When I turn this into my two equations of x minus 3 equals 8 and x minus 3 equals negative 8, I no longer need the absolute value bars. Okay? So you have to make sure that you drop those out when you make these equations. Now I just have two equations to solve. They're both a one-step equation. Add the 3 to the other side. Okay? So when I add 3, x could have been 11. Or when I add 3 in this equation, x could have been negative 5. Okay, so we have two answers. This x value could have been an 11, or it could have been a negative 5. Second example here, 4n, the absolute value of 4n minus 5 is equal to 18. So again, I know that this distance from 0 is 18. So think about what two numbers could have a distance of 18. Well, that's positive 18 and negative 18. So you make two equations here. Okay, this is where I split this inequality into two separate equations. 4n minus 5 could have equaled a positive 18, or 4n minus 5 could also equal negative 18. Then you solve them both, and in this case, these are two-step equations. Add 5 to the other side, you get 23. Divide by 4. It's okay to end up with a fraction. You end up with 23 fourths. Okay? Leave it as a fraction. You do not need to change things to decimals. Okay? Leave it as a fraction. Check to make sure that it is reduced. Then solve your other equation. Again, add 5 to the other side. You end up with 4n is equal to negative 13. Then divide both sides by 4. You again end up with a fraction, which is fine. So n is equal to negative 13 fourths. It doesn't reduce, so you're just going to leave it as that. Okay? You are able to go back and check your answers. All you have to do is take that value for x, plug it back in, and make sure that you actually get that this value has a distance of, in this case, 8, or in this case has a distance of 18 when you plug these back in. Okay. All right, last one on the front here. We have the absolute value of 5x plus 6 is equal to negative 14. Okay, now remember, this is telling me that this value has a distance of negative 14. Okay. Again, it's not possible. We cannot have a negative distance. So because you have an absolute value equal to a negative, there's no solving you have to do. You simply write no solution. Okay, so be very careful though with those. Make sure that you're watching to see if it's equal to a negative so that you're not solving it when you don't have to. All right, let's look at the back. Now, these ones are a little bit different, okay, because there's some extra values in the equation that the previous ones did not have. What's extremely important is before you split into two equations, you have to make sure that the absolute value is isolated. Okay, that means that the absolute value is by itself on that side of the equal sign. So in this first one, n divided by 3, the absolute value of n over 3 plus 2 equals 4. This is not by itself. The absolute value is not by itself. You have to get that alone first. So in order to do that, you subtract 2 to the other side. Then I have the absolute value of n divided by 3 equals 2 when I subtract that 2. Now, because this absolute value is by itself, there's nothing else connected to the outside of it. Now I can split into two equations. Okay? So this n divided by 3 could have been a 2 in there, or n divided by 3 could also be a negative 2. Okay, because again, this is asking you what values have a distance of 2 from 0, 2 or negative 2. Okay, then it's just a one-step equation. In both of them, you multiply by 3 on both sides. You get two answers, n equals 6, n equals -6. Okay. Same thing in these examples. You have to make sure that this absolute value is isolated first. That means that it's by itself. So right now, this has a -10 connected to it. You have to move that to the other side before you can split this into two equations. So we have to add 10. Then I have the absolute value of r plus 5 equals 15. Now this can be made into two equations. So this r plus 5 could have been a positive 15 in here, or this could have also been a -15. So r plus 5 equals -15. Again, one-step equations, solve them both. You get r equals 10 and r equals -20. So you have two possible answers. In this example, we have -8. This is -8 times the absolute value of 6 plus 6a. Okay? There is no symbol between the -8 and the absolute value bar. That means that it's multiplication happening there. So in order to undo this here, you have to divide both sides by a -8. And when you do that, then you get your absolute value by itself equals +6. Now you can make two equations. So we end up with 6 plus 6a equals 6, or 6 plus 6a could have equaled a -6. Again, solve them both. It's a two-step equation. You get a equals 0, or a could equal -2. Two more examples. In this one, again, I have to get this absolute value by itself first. This is a -7, so I need to add 7 to the other side. When we add 7, we get -52 plus 7 is a -45. Okay, so at this step, I have an absolute value of 8x plus 5 equals -45. Okay, again, absolute values can never be negative. So there's no way that this has a distance of -45. It's not possible. So you have zero solving to do. You just have to write no solution. Okay, be very careful. Make sure you're checking for that so that you don't go through a whole bunch of work that you didn't have to do. All right, last example, and this one's a little bit tough, but you have to make sure that you realize what operations are currently happening so that you can figure out how to undo them. We have 5 minus 6 times the absolute value of b plus 7 equals -73. Okay? This -6 is being multiplied times the absolute value because there's no symbol in between them. Okay, that means it's multiplication. So I'm going to have to deal with that last. The first thing we have to do is move this 5 to the other side by subtracting it. Okay, it was a +5. You need to subtract it to the other side. -73 divided by a -5 is a -78. Now you can deal with that -6. Right? We have to divide it to move it to the other side. So we end up dividing. We get the absolute value of b plus 7 equals, this division is going to turn this into a +13, which means because I have an absolute value equal to a positive, I can split this into two equations. Okay? Now again, remember, this is telling you that this distance from 0 is 13. So b plus 7 could be a 13, or it could be -13. Okay, they both have the same distance from 0. Solve them both, just a one-step equation. You get b equals 6, or b could equal -20. So again, you have two answers. Okay, most absolute value equations are going to have two answers with them. So be very careful, make sure that you're checking for a negative. If it's not equal to a negative, then you split into two equations and solve them both. Again, this is the very first concept in quarter 3. It's the absolute value equations.